Let me present my screen to you all. Just wait. My screen is visible, everyone. Hello. My screen is visible to you all. Okay. Okay, so listen everyone, in last class I have discussed, first of all of you know that for curve, this is the equation, just wait. X y square equals to x cube plus ax plus b, right? This is a curve of this type of form. All of you know that equation. Now then, after in last class, I have discussed if you want to find the points, right? This type of equation is given to you. Now, if I want to find the different points over this curve, then what you have to do, let's say this type of question is given to you, E1311. So where A is a 1 and B is 1. Okay, and the value of p, that is 13. So now in that, what you have done, different value of x you have to put. And so let's say first I am putting x equals to 0, right? When I put x equals to 0, then I am getting the two value. So y square equals to 1 more 13. So here you can say that which are the two values of y, that is plus 1 and minus 1. So for x equals to 0, the value of y, that is 1, and here it's a minus 1. So minus 1 plus 13 is 12 you are getting. These are the 2 points over the curve that you are getting. Similarly, you have to put the x equals to 1. Now, when you put x equals to 1 in this equation, which equation? Y square equals to x cube plus x plus 1. In this equation, when you put x equals to 1, then at that time you are getting 3. So see, each and every time you have to check whether the square roots are possible or not. So here it is 3. The square roots are not possible. So if the square roots are not possible, then you have to check whether it's a quadratic residue with respect to mode 13 or not, right? So that thing that I have explained, okay, how to check for. So A is a quadratic residue with respect to mode P. If A raised to P minus 1 by 2 mode P, that is 1, right? The two scenario. And if A raised to P minus 1 by 2 mode P, that is 1, then you can say that it's a quadratic residue and the solution is possible. But if a raised to p minus 1 by 2 more p, that is minus 1, then you can say that it's a quadratic non-residue. So listen, every time you have to check whether the square roots are possible or not. If the square roots are not possible, then you have to check whether it's a quadratic residue or not. So how to check for quadratic residue? you have to calculate a raised to p minus 1 by 2 mod p, and then you have to check it is equals to 1 or not. If it is 1, then it's a quadratic residue, and if it's a quadratic residue, then the solutions are possible. Then another is a, if it is minus 1, then it's a quadratic non-residue, and then you can say that the solution is not possible, right? So in last class also I have discussed this scenario. So in this case, the square roots are not possible, so you have to check for quadratic residue. So for quadratic residue, what you have to take, a raised to p minus 1 by 2 more p. So now here you are getting 1. So the meaning is it is a quadratic residue. And if it's a quadratic residue, now the solution is possible. So now how to get the solution? So in that I have explained you in last class. You have to check the value of this a. It's a perfect square or not. So here it's a 3, means the square roots are not possible. So it's not a perfect square. So what you have to do? So you have to add the p to this what a value. Okay, so now what you get 60. So whatever the new value that you are getting, you have to check whether it's a perfect square or not. And if it's not a perfect square, then again you have to add this p. So it becomes a plus 2p. So in this way, continue how to repeat the process. Okay, so this thing that I have explained. So here, when I am adding p to this a, I am getting 16. So I have to check the 60 is a perfect square or not. And if it's a perfect square, so I am getting 4 and 9, right? So that means these are the 2 points over a curve that I am getting. So this thing that I have explained in last class. So is it clear to you up to this, everyone? Is there any doubt for a point generation? Because in your lab session, the same thing that you have to implement. So that's why I have repeat this again. Is there any doubt? Hello, can you hear me? Is there any doubt, everyone? Please reply so I can understand. Hello. See, all of you are not communicating with me, right? So how can I understand you are getting or not? Okay, thanks for replying me. Okay, so in this lecture, you study about how to find the points on a curve, right? Now today I will explain you the operation on this. First, I will explain you the operations, right? So in the last lecture, you find the points on a curve. Okay, so now once you get the points on a curve, then you can apply the operation on that operation over that, yeah, that curve, because now you are getting all the points, right? Now between that points you can perform the addition. Any means you can perform the operations, right? So today I will explain you that thing. So see, first of all, listen. First of all, I will explain you the theory portion. So, from that, you see, for each and every case, you have to remember the equation, and then after some time, I will discuss. Just you have to remember the equation, and based on that, I will explain you the example. Right. So, this type of question can also be asked in exam. So, listen. Let's say E is the set of points over a curve. Okay, and operator is plus. So let's say you have to assume there are some points, set of the points over the curve, right? So already that we have calculated in the last lecture. So now there are some set of points that you have to assume. Now definition of the operator plus. So now consider see here, consider the 2 points over a curve EP, and where the parameter is A and B. So now you have to consider where P equals to x1 y1 and Q equals to x2 y2. Now here you can say that the operation is plus. So here you can say the operation is the addition of 2 points on the curve. So P is a one point on a curve where P equals to, I can say it is x1 y1. The coordinates are x1 y1, and for Q the coordinates are x2 y2. So in the operation here I can say that it's an addition of 2 points on the curve to get the another point, that is R, that is I can say x3 y3. Again, I repeat, here the operation is the addition of 2 points. Here it's a x1 y1, there is a x2 y2, and when I'm adding this 2 point, right, I get the another point, that is x3 y3 on the curve. So here I can say r equals to p plus q. So now see this figure. So now see here I can say that if you want to find the value of this r, right? So now see, basically here what happened in there are three different cases are there. If you want to get the value of this r means x3 y3. If you want to get the value of this r, then the three scenario that you have to remember. The case number one. So this is a case number one. In the case number one, what happened? In the first case, 2 points, that p and q. So p that is equals to x1 y1 and q that is equals to x2 y2 have a different x coordinates and different y coordinates. Okay, so this is the first case where both have a p and q have a different x coordinates and y coordinates. Now, now the line connecting this P and Q that intercept the curve at some point. The line connecting P and Q that intercept the curve at some point, and that is a minus R. And what is minus R? The minus R, that is the reflection of R, right? R is the reflection of minus R. So here it is when it is, you can say that when it is intercept the curve, and this point is known as minus R, and see it is a reflection of R. So here you can say that it is what, x3 and then comma minus y3. So uh, now, see, basically the purpose of this case is what you have given a 2 point, x1, y1 and x2, y2. Now, what you want to find? So, when I'm performing the operation on this 2 point, I am getting a what? I can get the another point, okay, on the curve, that is x3, y3. So now, basically, the purpose is, that is, I want to find the value of this x3, y3. Okay, so the coordinate of the point r, x3 and y3 can be found by first finding the slope of line, right? By first finding the slope of line lambda and then calculating the value of x3 and y3. So the slope of the line joining points P and Q. So all of you know that here it's x1 y1, here it's x2 y2. So how can you write the lambda? All of you know that the slope of the line lambda, that is equals to y2 minus y1 divided by x2 minus x1. Okay, now here you can say that the line joining P and Q that also intersect the curve E at minus R, that is what, x3 comma minus y3. And all of you know, according to the equation of line, you can write in this way, y minus y1 that is equals to lambda x minus x1. Up to this clear, everyone? What I'm trying to say, basically the purpose is to find out what x3 and y3. You have given 2 points on a curve. If you want to find the plus operation, right? And here the case number one is where both the coordinate means x coordinate and y coordinates are different. This is the first case. So in that case, if you are performing the addition operation on 2 point, then the problem is you have to find the value of x3 y3. So up to this clear, everyone? What is my task? Hello? Is it clear to you all? Okay. So all of you know we know that the according to the equation of the line, you can write y minus y1 that is equals to lambda x minus x1. Okay, so it's a slope point. It's a slope point equation. So now all of you know that in this equation one, I can say that the point x3 comma y minus y3 is also on a line. Yes or no? Right? This is the line equation. And we can say that, see, this point that is also on a line. So this x3 comma minus y3 is also on the line. So that means you can say that the equation 1 that satisfied, you can say that instead of this y, can I write minus y3? Instead of this x, I write what, x3, because this point is on the same line. So here I can say that y3 plus y1 that is equals to minus lambda x3 minus x1. So what I get, y3 equals to minus lambda x3 minus x1 minus y1. And therefore I can say that y3 that is equals to lambda x1 minus x3 minus y1. So here you can say that since x3 y3 belongs to this curve, so See, so here I'm getting this equation. Now all of you know that this point x3 y3 that is also on this curve. Okay, it also on a curve. So if it is on curve, then all of you know the curve equation. So I can write, all of you know the equation of curve, that is y square equals to x cube plus ax plus b. But here I am considering x3 y3 point. So that's why instead of y I am writing y3. So here what I am getting, y3 square, that is equals to x3 square plus ax x3 plus b mod p. Up to this clear everyone? Hello, is it clear to you all? Hello, can you hear me? Okay. So this is a y3 equation, right? So what I'm doing here, so this x3 y3, it also belongs to curve. All of you know that according to this figure. So see, first of all, what I have done here. So now it is on a curve. So instead of that, what I can write here. So all of you know that instead of y3, I can put this value. Okay, these x3 cube plus ax3 plus b, right? So you can write in this way, it's a lambda square. In bracket I can write in this way, x1 square minus 2x1 x3 plus x3 square minus 2 lambda y1 into x1 minus y3 plus y1 square, right? It's a simple math, so all of you know that, equals to x3 cube plus ax3 plus b. Now I am arranging the term. Now see, lambda square x1 square minus 2 lambda square x1 x3. Now see, in this way I am evaluating it. Now after that, what I have happened, I am arranging these all terms. So I am writing in this way, x3 cube minus lambda square, just wait, x3 square plus ax3 plus 2 lambda square x1 x3 minus 2 lambda x3 y1 plus b minus lambda square x1 square plus 2 lambda x1 y1 minus y1 square, that is equals to 0. Now see, when you observe here, if I think it as a polynomial of degree 3, right, then we will rewrite in this way. So I'm arranging this term in this way. So here I can say that according to the if I'm considering it as a polynomial of degree 3, so what I'm doing here, I'm putting the x instead of in place of this x3. Okay, so I'm getting this type of equation. Means it is which type of equation? All of you know that polynomial equation, ax3 plus bx square plus, let's say, considering this term as a cx plus considering this term as a d. Okay, so it is a polynomial type of equation. It's a polynomial equation. And so if we say the solution, if it's a polynomial equation, then the solution of the polynomial equation is a alpha, beta, and gamma. So all of you know that the quadratic equation, right? So which are the square roots? All of you know that which are the square roots of that quadratic. So here you can say that if it's a polynomial equation, then the solution of this polynomial equation as alpha, beta, and gamma. Then can I write in this way, alpha plus beta plus gamma, that is equals to, all of you know that if it's a polynomial equation, then the solution is minus b by a. And what is that? So all of you know that ax cube plus bx square. So that means what you have to do, the first b means you have to take the coefficient of x square, and the a, that means you have to take the coefficient of x cube, right? So what you get here, lambda square you get. So that is alpha plus beta plus gamma, that is equals to lambda square. So what you get, gamma equals to lambda square minus alpha minus beta. Now listen everyone. So here in this case, all of you know that this point x1 y1 x2 y2 x3 y3, that belongs to this EP, right? So now if it is on a curve, so whether I am putting here x1 y1, or I am putting x2 y2, or I am putting x3 y3, all satisfy this polynomial equation. And if it satisfies the polynomial equation, then can I write in this way x1 plus x2? Because here for polynomial I am getting this answer. So instead of this, can I write x1 plus x2 plus x3 that is equals to lambda square? And that's why I am getting x3 that is equals to lambda square minus x1 minus x2, right? So see, basically what is our purpose? So here you have given some points, you have to apply the plus operation, and then based on that you have to get the value of x3 y3. So again I repeat that thing that you can see up till now what I have learned, just again I repeat so you can understand. See here the operator plus is given. Now how to generate the set of point? Now all of you know that in last lecture I have explained. Now once the set of points over a curve you are finding, now I want to perform the operation on this point. Okay, so here the 2 points are given. Right now you want to find another point on a curve, that is x3 y3. Okay, so basically here what you have to do, so if you want to calculate this thing, then what you have to do? So first of all, you have to calculate the slope of line joining the points P and Q. So the your question is, I want to find what is the value of x3 and y3. Okay, so the slope of line joining the point, that is y2 minus y1 divided by x2 minus x1. And all of you know that here in this case, the line joining P and Q that also intercept at this curve, that is x3 comma minus y3. And that's why all of you know the line equation, that is y minus y1 equals to lambda x minus x1. And see this point is also intersect on the line. Okay, so here you can say that instead of this x and y, can I put x3 comma minus y3, right? And once you put all this value, you are getting y3. Okay, so here you are getting the y3 value on the curve. Now, see, basically this x3 y3, it is also on a curve, and all of you know that if it is on a curve, then it's what is the equation for of curve? That is y square equals to x cube plus ax plus b. So instead of this y, I am writing y3 because here I have the coordinates are x3 y3. So if you are putting all these values, so here I am getting this type of equation. So here I have assumed that see here from this equation I can say that it's a polynomial equation, and if it's a polynomial equation, then the solution is what? The coefficient minus of coefficient of x square by coefficient of x cube, right? So here you are getting this lambda square, so that means you are getting alpha plus beta plus gamma, that is lambda square. Now here I can say that, see, if I am taking here x1 y1 or x2 y2 or x3 y3, any coordinate if I am taking, so I am getting this polynomial equation. And if I am getting the polynomial equation, then obviously the solution is what? X1 plus x2 plus x3, that is lambda square. So now I am finding x3 equals to lambda square minus x1 minus x2. And see, remember that here I have considered that these 2 points whose coordinates are different. So this is the first case, right? If you want to perform the operation, if you want to get the value of this x3 y3 where the operation is plus, so the case number one is where the coordinates are different, right? So now see, you have to remember this equation because next I will explain you example in that this equation will be very useful. So this thing that you have to remember, if p is not equals to q, means the x coordinates and y coordinates are different, and if you are performing this operation on this 2 point, the addition operation on the 2 point, and where the coordinates are different, so at that time you have to remember this formula. What is the x3? X3 is calculated by using this formula, lambda square minus x1 minus x2 mod p. And how to get y3? Y3 that is equals to lambda x1 minus x3 minus y1 mod p. So here you have to write mod p because all of you know that in crisp arithmetic it must be in the range of that mod p. So write down this formula, everyone. You have to remember this. So I will give you a time. Write down this formula. So in first case, is there any doubt, everyone? Hello. Is there any doubt in first case? Please reply so I can understand. I think all are clear. So write down this equation. See, now after 10-15 minutes, I will give you one example. You have to tell me which formula I have to use. Priyank, right now I don't have that device. Hello, Priyank, can you hear me? Okay. Is there any doubt in this first case, Priyank? Where you are not getting, Priyank? Can you unmute yourself? Hello, Priyank.
I am just telling that if it is possible to do this calculation using a pen and paper, then it would be more clear.
See, there are lot of calculation, Priyank. So see, some of the example, if it is possible, then I will write, because see, it's a theory part. See, right now, actually, yes, directly I will solve this type of example, right? But see, for that, how we are getting this equation. So for that, today I will explain you this theory part. Okay, so how exactly means each and every scenario, like in this type of scenario is there, then what is the value of x3 y3, right? So see, if I am writing each and everything by using pen and paper, then it's not possible for me. It's not a blackboard, so it's a very tough task for me, Priyank, right? And some time constraint is also there. So within a 8 lecture, I will not be finished your syllabus. Your syllabus will not be finished, right? So in example I will do in that way. Okay, I will write by using
Okay.
pen and paper, I will show you. But see, this is a theory part. By using, I will explain you how exactly you are getting this point. So each and every thing is not possible, otherwise your syllabus will not be finished, right, Priyank? Priyank, is it clear first case? Hello, can you hear me? Okay. Okay, so now listen, the first case that I have explained, that is if you want to perform the addition on a addition, or you can say that on a 2 points on the curve, so you get the third point, that is x3 y3. And the case number one is where x coordinates and y coordinates are what different. This is the first case. So now see, just you have to remember this formula, but see, by using, I have explained how exactly you are getting. So the two formula you have to remember. If the p and q are different, means the x coordinates and y coordinates are different, and when you are performing the addition on these 2 points, then what is the value of r, that is x3 y3, that is by using this formula you can get the another point on the curve. Okay, so this equation you have to remember. Now the case number 2. So what is the case number 2? If p equals to q, what is the meaning of p equals to q? So that means here you can say that in the second case, In this second case, you can say that the 2 points overlap. The 2 points that is overlap. So here you can say that P equals to Q, right? So then the line will be tangent to the curve, right? So here you can say that. So in the first case, how you can find the slope? So all of you know that in this scenario, you can find the slope by using this formula y2, because the x coordinates and y coordinates are different. So here you are getting y2 minus y1 divided by x2 minus x1, right? But here in this case, what happened? See here, if P equals to Q, so then the line will be the tangent into the curve, and the slope of the tangent, that is what, dy by dx. Okay, and all of you know the formula y square equals to x cube plus ax plus b, right? So how to find this derivative? So all of you know that y square, that is, it becomes what, 2y into dy by dx equals to x cube, means it is what, 3x square plus a, and it is 0. So that's why what you get, the value dy by dx with respect to coordinate x1, y1. I can write in this way, 3x1 square plus a divided by 2y1 equals to lambda. So this thing that you have to remember, how to calculate the lambda. Otherwise, in the case number 2, if p equals to q, then all of you know that if I perform p plus q, that means the both the points are same. Either you write p or q. So p plus p, that means it becomes 2p, right? So r equals to x3 y3, that is 2p. So now, where how to calculate the x3 y3? See, the formula remains same. The formula remains same, right? Uh, uh, Nothing you have to perform it again. So now, how to get this x3? So x3, that is what? Lambda square minus x1 minus x3, but x1 minus x2. But all of you know that if the both the points are p and q, the 2 points are overlap. So here I am considering it as the same point. So it becomes what, lambda square minus 2x1, and y3, that is equals to what, this is lambda x1 minus x3 minus y1 mod p. So remember this equation, you have to remember, if p equals to q, that means in the second case the 2 points overlap. So in this scenario, when you are performing the addition of 2 points, so it is what, it is p plus p, because both the points are same, so it is 2p, and that is equals to x3 y3. So where, how to calculate the value of x3? So x3 you have to calculate by using the lambda square minus 2x1 by using this formula, and y3 you can calculate by using this formula. And how to calculate lambda? So at that time, for lambda, this equation you have to use. Again, I repeat everyone. So next I will explain you an example in that this equation that you have to use. So what you have to remember, if you want to perform the addition on 2 points, and where the x coordinates and y coordinates are different, so in that scenario, the lambda you have to calculate by using this y2 minus y1 divided by x2 minus x1. And then after, how to find the value of x3 and y3? So for that, this equation you have to use lambda square minus x1 minus x2 mod p, y3 equals to lambda in bracket x1 minus x3 minus y1 mod p. Okay, so this formula you have to remember, when lambda is what, y2 minus y1 divided by x2 minus x1. Now the second case you have to remember, where the 2 points overlap. So in that scenario, how to calculate the lambda? The lambda is calculated by using this equation. Write down everyone this equation, 3x square plus a divided by 2y1. Okay, and then how to calculate the x3 y3? So here the same equation for x3 y3, same equation is used, but see, now the both the points are same because the 2 points overlap. So that's why here the I have written lambda square minus 2x1. Okay, and the y3 remains same as it is. So up to this clear everyone? The both the cases. Is there any doubt? Hello? Is there any doubt? Can you hear me everyone? Hello? Okay. Now the third case. So the two scenarios that I have discussed. Now the third case number 3. In the case number 3, what happened? The two points are additive inverse of each other. The 2 points are what? Additive inverse of each other. So here I can say that if my P point, that is x1 y1, then the second point is what? Q, that is x1 comma minus y1. So that is, I can say that Q equals to minus P. So third case, the 2 points are what? Additive inverse of each other. And so that's why you can say that P is x1 y1, the second point Q, that is x1 comma minus y1, and that is Q equals to minus P, right? So here I can say that the line joining P and Q, this line joining P and Q that doesn't intersect this with this curve, right? Earlier what happened, whatever the line is joining this point, that is that is you can say that connect that you can say that is intersect with curve. But here you can say that the line joining to this, it doesn't it is not intersecting the curve at the third point, right? And that's why, right, that's so see in previous two case what happened, you find it is intersecting the curve at some point, but here it is not intersecting the curve at third point. And that's why the mathematician says that the intercepting point is what? Is at infinity. The intercepting point is at infinity, and they define a point 0 as the point at infinity or 0 point. Okay, so these act as an identity of plus operator, and that's why you can say that P plus 0, that is equals to P. Okay, so it's an additive identity. Now the E set of point over this curve where the operator is plus, it forms the abelian group, right? Now can anyone tell me which are the properties of abelian group? Now the question is, the set of points over E, it's a set of points over this curve, it forms a abelian group, right? So which is satisfy the properties or not. So which abelian group satisfy which property? Which properties are there in a abelian group? Please write down your chat window, everyone, quickly. Hello, closer, right. Next property, everyone, I want the answer for everyone, from everyone, not one or two person. Only one or two people give me the answer. Yes, good. Yes, correct. Okay. So listen here. You can say that when why you can say that it forms a abelian group. So if it satisfy all the properties, right? So first one by one it will one by one check it. So the first property, that is closure. That means it can be proven that adding the 2 points as defined earlier can create another point on the curve, right? That we have already seen. So if you are adding the 2 points, can create another point on the curve, right? So that means the closure property is satisfied. What is the associative? Means if you are adding the 2 points, so P plus Q, so that means P and Q, this you have to consider as a point, right? So this associative property is satisfied, as well as the commutative property is also satisfied. Identity that already that we have in the last case, that is the 0, that is the point at infinity, is the additive identity, right? Additive identity that already that we have seen. So this additive identity, we are getting the same P, right? So this property already that I have explained. And the last property, that is inverse. So for every point P on the curve, there exists a point Q such that P plus Q, that is equals to 0, right? So this property that already this property already that I have explained, that is if I am taking P as a x1 y1 and Q as a x1 minus y1, right? So such that I can say that P plus Q equals to 0, the case number 3, right? So that's why you can say that all these properties are satisfied, and that's why it's a abelian group, right? So one point is that um, the EPAB must be non-singular, and that is 4a cube plus 27b square not equals to 0. So this one not. So one proof is there, but right now I will not explain you that proof. So is there any doubt, everyone? Hello? They are the three cases that I have explained. So now next I will explain your properties. So two things that you have to remember. Okay. So my question is, this type of point I will give you. Okay. The mode also I will give you. Now, if you are performing the addition, so first you have to check if the x coordinates and y coordinates are different. So for calculating the lambda, this equation you have to use, and for finding the x3 and y3, this equation you have to use. Which equation? So see here, x3 that is equals to lambda square minus x1 minus x2, and y3 that is equals to lambda x1 minus x3 and bracket minus y1 more p, right? And the another is, if both the points are same, right? The 2 points overlap. So in that scenario, how to calculate the lambda? For that, this equation you have to use. And what is the value of x3, y3? Why it is 2x1? Because the x1 in this case, x1 and x2 both are same, right? So that's why I can say, because the both because the 2 points overlap, and that's why here I can say that x3 that is lambda square minus 2x1, and y3 that is lambda in bracket what, just wait, x1 minus x3 minus y1. Okay. So this is the second scenario that I have discussed. And case number 3, that is what, the two points are additive inverse of each other. Okay. So the line joining P and Q that doesn't intersect, and that's why the mathematician says that the intercepting point is at infinity. So all of you clear up to this? Can I explain you example? Theory part is clear to you all? Please reply. Is there any doubt? Hello? Is there any doubt? Yash, Abhi, Priyank, clear? Okay. Now, next I will explain you example. I think you all are clear. Okay, so this type of question is asked in exam. So now see here, one point is given P equals to 4, 2. So in like here, you have to assume these are x1, y1, and these are x2, y2. Okay, so the two points on a curve that is given to you, x1, y1, and x2, y2, and the prime means P value that is 30. Okay, now the question is, find out R. R means some points. So if you are performing, these are one point, these are another point. If you are performing the addition operation on this 2 point, you are getting the another point, that is R. Okay, R means you can say that another point that you are getting, and its coordinates are x3, y3. Okay, so now which formula, how to calculate the value of this x3, y3? So all of you know that. So the three cases that I have explained. What is the case number 1? So here the x coordinates and y coordinates are different. So that's why which formula you have to use? that is lambda that is equals to y2 minus y1, y2 that is y2 that is 6 minus y1 that is 2 divided by x2 that is 10 minus 4 mod 13. Okay, so that means what you get, 4 multiplied by 6 inverse mod 13. So what you get, 4 multiplied by 11 mod 13, right? So finally you get 44 mod 13. So what you get, 5. What you get, 5. Now you get 5 value. So here I can say that the lambda value that I am getting. Now once I get the lambda value, now then after what I have to, so basically my purpose is to find the coordinates x3 y3. So for x3 y3, first you have to find out this lambda by using this formula. Once you get the lambda value, now I am using this formula, that is x3. See, before that, I have explained a theory how I am getting this equation, right? Now, how you am getting this equation? So, x3 equals to lambda square minus x1 minus x2. So, what is lambda? Lambda that is 5, so 25 minus what is x1? X1 that is 4 minus x2, x2 that is 10, right? And that's why here you get the answer x3 equals to 11 and y3 equals to this equation you have to remember, that is lambda x1 minus x3 minus y1 mod prime, right? So lambda that is 5, x1 that is 4, minus x3 that means 11 that you are cutting, minus y1, y1 means 2 value that you have to take, right? So when I put all this value, so what I am getting, so the x3 y3 coordinate means, see, x3 is 11 and y3 is 2, means I am getting this answer, right? So is it clear to you all up to this? Now, Priyank, can you unmute yourself? Hello? Priyank, can you unmute yourself? Can you hear me? Hello? Now clear? Okay. Okay, now listen everyone. See here, this type of question is, this type of, here the curve is given to you where the value of A is 1, value of B is 1 and these are point P equals to 1 for, these are the coordinates. Okay, so this is a point on this particular curve is given. Now the question is asked, that is find 2P, find 2P. Right. So all of you know that instead of 2p, can I write p plus p? Yes or no? And here only one point is given. Right. So now which case is used, everyone? Can anyone write? Can anyone write in the chat window? If only one point is given to you, then the, okay, second case you have to take, right? So now see here in our scenario, so the case number 2 is applied, and when the case number 2 is applied, so all of you know that for calculating the lambda, which equation you have to use? This equation, 3x square plus a by 2y1, right? So now see here, so if case number 2 is applied, then for calculating the lambda, this equation you have to use 3x, 3x1 square a plus 3x1 square plus a divided by 2y1. So now, but I have to use this formula. I am putting x1 as a what, 1 and y1 that is 4. So now I am calculating it. Here 8 inverse more 13. So I am getting 5 answer. So finally the lambda that I am getting 7. Okay, so in this way I will calculate the lambda value. Now once I get the lambda value, then how I calculate the x3? So all of you know that if only one point means the 2 points overlap in that case, right? So here if only one point, so in this scenario, here I can say that the x3 that is equals to this formula I am taking, lambda square minus 2x1 more p, right? And y3 equals to this formula that you have to take, right? So x3 equals to lambda square minus x1 minus x2, and here only one point means both x1 and x2 are same. right? So it is 1 4, you have to remember. So this is what here I put 1 1. So what I get here 8, and what is the value of y1? That is 4 here, right? So lambda, that is 7, x1, that is 1, minus x3, that is 8, minus 4 more 13. So finally what you get, y3, that is equals to 12. So now here I can write in this way, 2p equals to p plus p, x3 equals to x3 by 3, and that is equals to 8 comma 12. So for 2p, the answer is what? 8 12. Up to this clear, everyone? Is there any doubt? Hello? Is it clear to you all? Can you hear me? Okay. Okay. So listen here. Now this is a second example. In third example, what I want to calculate. So all of you know that now in example, see if the point coordinates, that is 1 4. So if this coordinate 1 4 is given, and if you are finding the 2p, so what I get the value, 2p equals to 8 12. So now the same point that I am considering, the same point coordinates that I am taking, p equals to 1 4. Now in that scenario, if my question is I want to find 4p, okay, so now all of you know that 4p, that is what? 2p plus 2p, 2p plus 2p. So 2p, that means one point is 812, and again 2p means 812. So that means the same point is there. So again what happened? Again the case 2 can be applied, right? Because the 2 points overlap. Basically, if you want to calculate the 4p, then first you find what? 2p, right? See, in exam, if this type of point I will give, okay, if this type of point I will give on a curve, now I am asking you a question, find 4p. So first what you have to do, now the p is given to you, right? So what you have to calculate, 2p equals to p plus p, right? So you know that the 2 points overlap. So that means you can say that the case number 2 is applied. When the case number 2 is applied, first you have to calculate the lambda by using this formula, and then x3 and y3 by using this formula. So now for this particular point, you are getting the value for 2p, right? So which value that you are getting? That is 812. But see what question I have asked? I have asked the question that is you have to calculate 4p. So before 4p, first you have to calculate the 2p. Once you get the value of 2p, now then after you have to calculate now 4p. And 4p, that is equals to what? 2p plus 2p, right? So that means 812 plus 812, right? So that means here the case 2 will be applied, and when case 2b will be applied, the same thing that you have to perform. First calculate the lambda by using this formula, 3x1 square plus a divided by 2y1 mod prime, right? So here instead of x1, what is the value? x1, that is 8, right? And y1, that is what? y1, that is 12, okay? And what is the value of a? The value of a, that is sorry, okay, huh. Just wait. The value of A, that is this one value, A and B, this on the curve that is given, right? So that you have to take, okay? So now based on that, you are getting the lambda. Then again you can calculate sorry, x3 and y3, and finally you get the value for 4p, 11 11. So up to this clear, everyone, how to calculate for 4p? Yes or no, everyone? Hello, can you hear me? Okay, now you tell me the answer. Suppose, see, now again one example is remaining, but that I will explain you in next class. But see, before that, you tell me if I want to calculate 5p, 5p, then what you have to do? Can anyone explain me? Abhi, can you explain me? If I want to calculate 5p, then what I have to do? My question is, see the chat window. I want to calculate 5p. And what I have to do? Abhi, can you hear me? So please tell me, unmute yourself. Abhi, whatever you understand, please reply me. Yes, perfect, Prince. First calculate Q equals to 4p and p, then applied case number 1, right? But see, so actually basically what's the procedure? So first of all, for calculating 4p, first you have to calculate 2p. See, first you have to calculate 2p. Once you calculate 2p, then what you perform? 4p, that is equals to 2p plus 2p. Yes or no? Right? So when you calculate 2p, so at that time, which case you are performing? Case number 2. Again, you have to calculate 4p. So at that time, 2p plus 2p, again, you calculate the case, use the case number 2. And then after, now when you calculate 5p, then it is equals to what? 4p plus 1. Sorry, 4p plus p. So now case number 1 is applied. Now is it clear, everyone? Is it clear to you all? Any doubt? So please calculate it and tell me the answer. Now see, all of you have this value 4p, 11, 11. Okay, and you have this point. Please write down, everyone. Write down the curve. Please do it fast. There is a point on the curve. Now you have this 4p value. Now calculate the 5p. Then tell me the answer. Okay, Prince says minus 8, 7. Okay, I will check and then after in next class I will reply you. Okay. Okay. Thank you, everyone.
Good afternoon, all. Am I audible to you?